pressure gauge. It's going to go up. So, give me a number. How high do you want that pressure to go? Give it to me in torr. 700 torr. Okay. Now, we're going to stop. Turn this off. Okay. Then what I'm going to do is I'm going to take liquid nitrogen and I'm going to put on that tit. And when I do that, what's going to happen to this gas right here? It's going to change to a solid. So basically I will have SO3 ice in the bottom of my flask. Does that make sense to you? So I've taken a gas, I've changed it to a solid using liquid nitrogen. It means I have made ice. And it turns out that as far as pressure goes, it will follow that cold finger. So all of that gas that's up here will actually start sucking this direction, so you can kind of make what's called a cold vacuum. All right? Are you happy? Wonderful. Then what we're going to do is we'll change out and we'll put down a nitrogen tank now. Okay? Start leaking that in. What's going to happen to the pressure? Go up. We're going to put a container on here. Now what have we got? Well, now there's going to be a layer of nitrogen sitting there on top of that SO3 ice. Does that make sense? Let's say that the pressure gauge read 327 torr. We got one more thing to deal with is oxygen, so we go find ourselves an oxygen tank. Do the same thing, and now we've got yet a third layer in there. So you see how we've got 3 layers now? 400 torr. Now, pull all this out, turn on the vacuum, close this, pull this off. Now you have a gas bulb in your hands. And let it melt. Let all this stuff melt. What will then be the total pressure inside of that flask? Add them up. Well, let's do it. Add them up. How much? Let's be 1427. All right. So the total pressure inside of this flask is 1427 torr. Okay. You happy with that? Okay. These right here are what are called partial pressures of oxygen, partial pressures of nitrogen, and partial pressure of SO3. Dalton's law of partial pressure says this: that the total pressure inside of a flask equals the pressure of gas A plus the pressure of gas B plus the pressure of gas C, and so on. The partial pressure, they call that. Which means if the gases are not reacting, okay, whenever you add all of those things up right there, they're going to equal a total pressure addition. Does that make sense? Yeah. Yes.
So if you have like all the pressures like at 700 and they're all solids in there, and you take it off and melt it, could it make it burst? If you melt it,
oh yeah. If all the pressures were at 700, yeah.
But it's like as a solid, it's still be split.
As a solid, you could be okay, but then as it started to melt, the pressure would go up inside the thing. And by the way, when you measure the pressures, you know you're measuring it when this is not solid. All right. Yeah, I'm talking about the final inch when it's not solid. Yeah, if you go overkill on this, you can actually rupture the glass. Yeah, so you have to monitor that, right? Because 760 here is 1 atmosphere. Now, you can go a little bit over that because glass is relatively strong, but certainly it would explode on you.
I'm kind of curious about something. Have you ever had to use liquid nitrogen? Like
Oh, yeah.
Use it?
Yeah, this is how you do it. Thousands.
What can it really do?
Thousands. What are you talking about?
Like, could you take this pin, stick it in there, and it just break it down?
Yeah.
Really?
I used to do that thing because at Auburn you had an in-house liquid nitrogen. And, you know, you could just get tons of it for free. You know, oh yeah, liquid nitrogen, we froze all kind of stuff. Pencil erasers, that's a good one. Something rubber, like a rubber ball that you could sit here and bounce, like my kids got these things that goes all over the place. You drop that in there, let it freeze, drop it, it shatters completely. And one time I did this demo, and I know this is so bad, right? But I guess I'm this type of person. I took a pair of rubber gloves, and I was asking a group of freshman students, well, what would happen if you froze your finger? Now inside those yellow rubber gloves, guess what I hid? Piece of hot dog about that big. So I put on the rubber gloves, except of course like one finger was bent like this. And I was right here in front of this girl, and I stuck my finger in there and I went through the motions. Oh, you know, all this, till it got froze. And then I had a hammer laying right here. I went and I hit it. So then this hot dog went shattering. She thought I'd busted my finger up, right? But it goes in little bitty shards all over. Yeah, liquid nitrogen is fun to tinker with.
Is that what they do with the warts?
Yeah. Yeah, they can freeze warts and various things with them.
Would your finger really shatter? Like?
Oh yeah, if you stuck it in that for a long period of time, it would. Yes. Now, like when you work with it for 5 years, I mean, your finger will get in here by accident, but as long as you pull it out real quick, you're okay.
Like, how long would it take if you just stuck your finger in there just for it to shatter into like a million pieces, or even just to get?
You wouldn't be able to handle the pain, but if you could handle the pain, probably 1 minute and 45 seconds, 2 minutes.
No.
Yeah. But you couldn't handle the pain. It's just so cold.
Metal is okay because they use the metal forceps to apply to the skin.
Right, yeah. Dermatologists have it figured out. It's not a whole thing that they dip your entire finger in. What's that now?
Metal when it shatters?
No, I've never got metal to shatter. I've tried it, but never have. I put a hammer in it once. Only thing I've not put in liquid nitrogen is an animal, right? I'm not an animal lover, but just couldn't do that, right? So.
Y'all didn't have like dead stuff like frogs or something just throw it in there?
I guess if you had a dead frog. I don't know. I just never have been one to get jazzed up over animals. I just don't think that's cool, you know. I mean, if there's a reason, like, you know, when I took biology, I had to dissect cats and that, and you're learning. I mean, there's a reason. But just to maliciously put a dead frog inside of liquid nitrogen to see what would happen, no, I never did that myself. All right, are we happy? All right, so what about safety? I got to ask you this, since you're asking me these questions. We got this container. It's got these gases in it. SO3 is extremely poisonous. Now, what if I drop that SO3?
You go nap for a long time.
What do you think?
If it's a solid, or is it a gas?
No, it's a gas. What would you do? If you dropped that, what would you do? Put a like you got time to do that, right? And one of the things you do is you hold your breath.
Praise God.
All right, but you have to practice this. Hold your breath right now. Go. Okay, now raise your hand if you did not suck in first.
Yeah.
All right. So actually, whenever I was first getting trained, all right, to use this, they would not let you use SO3 until they thought that you were okay. Is they would start you using nitrogen and like helium and argon. So why would they do that? In case you did drop it, nitrogen ain't going to kill you. Does that make sense to you? So then you have to go through these drills to practice the holler, hold your breath. But you have to hold your breath but not suck in first, right? Because if you suck in first, you've defeated the purpose. Then
You only have to have your breath like for 2 seconds, but it's
yeah, you would hold your breath and simultaneously